Is Amanpreet Puri, and I was working with Khushleen Singh, and this is our CS2316 NBA data analysis project. Unfortunately, Kush is sick and lost her voice, so she'll not be able to talk on the presentation today, but I'll take care of it. So the purpose of our project was to define relationships between the usage and your relative position in salary. So usage meaning how often a player is used on a court, and position meaning whether they're part of the front court or back court. The back court are the positions like the guards who handle the ball, and the front court are the rebounders and blockers and defenders. And we relate this to the salary, which is available online for every NBA player. The next relationship we seek to define is between the physical attributes of each player and how much they're being paid by NBA teams. This indicates the financial liability teams are willing to take for if your attributes contribute to that. We'll determine that and examine that in our analysis. And then next is to confirm the financial liability of NBA teams in regards to the actual game, meaning are NBA teams really paying their players to play more minutes? How much are those minutes worth? What threshold do you have to hit to be paid a certain amount as a player? And our analysis seeks to answer those questions, and we will do that later in our analysis as well. We will cover our data collection process by visiting each of the links which we got the data from. Use three different sources of data. One was an API source, one was a downloaded source, and one was a web scraping source. For our API source, we use Ball Don't Lie API to get player attribute information. So it returns a JSON with the first name, last name, the height in feet, inches, and weight. So we wanted to use this to get the collection for all the players' attributes. Next, for the web scraping requirement, we went into this table on ESPN.com for all of the NBA player salaries and went through each row and appended the name and the salary for each player, which you'll see the code for in the phase 3 IP, Y, and B. And for the raw data download, we got the entire 2021 to 2022 NBA season using all of this data that they provide for every NBA game. Process, we will go to our phase 3 notebook file and examine the code, and then as well we will look at the final clean data after it was cleaned. Requirement cleaning for this data parser method, what we did was we read it from a CSV into a data frame, and then we dropped all the columns that we did not need, and we only wanted to look at games that were decided by 10 points or less to avoid having skewed data. Then we calculated a usage rate, so a high or low impact for each player based on the usage percentage and minutes of that player and compared to the mean. And then based on the position type, we assigned them a relative position of front court or back court to see where they were playing on the season. So after this downloaded data requirement cleaning, it was a 55 megabit file when we got it with 30-something thousand rows, and we got it down to a 8 megabit file, which looks like this for every NBA season with our desired data and all of our desired columns. Our web request collection requirement, we had to go through 13 pages of these salaries. As mentioned earlier, we went through each row in the table, so you can see that code here in the row in odd rows and for row in even rows, and then we were able to append the name and salary of that player, and we will use this to merge with our other data frames later in our analysis, but this is what our CSV file looks like after we do that cleaning and append to our data frame and export to our CSV. Collection requirement, we went to Ball Don't Lie API, and we had to access each page for all NBA players, and you can see that total pages, and we iterate through each page to get all the players on all the pages. Something interesting we had to do, so first we're able to append our height and feet, inches, position, weight for each player, as well as their name and last name, their first name and last name. But something we had to do to get around the rate limit was to have the program use the time.sleep from time and request only every 1 or so seconds, so that little delay allows us to get around the rate request. But we're able to get all of our player information into this CSV file here. Analysis, insights, and visuals. To map a impact and relative position rating to what a player's salary could be on average. So here, all the code is commented. So we read the salaries into a data frame, and we read the NBA season into a data frame, and we initialize values for each combination of players. Here we mask our NBA stats data frame to get all the players for each category, and then we can group by that player and impact rating and count to be able to determine whether that player has more high impact games or low impact games. And based on that, we can iterate through and group them into a front court and back court with the same process for grouping with position. And then we can get our combinations and put them into lists. Here, we iterate through all of the rows in the NBA stats, and if this player in the list is present in all of the lists and in our data files, then we can append them to be able to map them with their salary, which is what we do here. We open our players' salaries, and we're able to go through each row of that and append the salary to the player for each category: front low, back high, back low, front high. And then we use our statistics module that we imported with the median and mean functions to put the values into our data frame here. So you can see that a high impact backcourt gets paid the most out of all of the categories, and the high impact players are paid a lot more than the low impact players. And there's a very stark contrast between high impact backcourt and high impact front court, which means high impact backcourt is teams are willing to take on more financial liability for those type of players. I wanted to determine how NBA players are paid based on their height. This also includes visualization number 1, but for insight number 2, our final data frame that we came up with was the shortest and tallest players, as well as the highest and lowest paid players. So we can see the shortest player actually is the lowest paid player in the NBA, and our visualization also supports that, but the tallest player is not the highest paid player. However, the tallest player is being paid about 20 times how much the shortest player is being paid. And how we got to this data frame is we inputted our players' salaries and players' infos, and we proceeded to merge the data frames and locate in these sorted data frames the tallest player in the sorted height, the tallest and shortest player in the sorted height one, and the highest and lowest paid in the sorted salary one. And we used iLook to get those rows, and we put them in our data frame. We did a scatter plot charting height in inches on the x-axis and salary in tens of millions of dollars on the y-axis. We can see that there's not really a correlation between increasing height and increasing salary. However, we do see a very light normal distribution, with most of the highest paid players being between 75 and 82 inches about. So this is the prime category for being paid a lot as an NBA player. See, how does the median salary of shorter NBA players compare to the median of the taller NBA players? Sorry for the typo here. But to investigate this, we took all of the height of all the players in inches, computed the median, and took the tall players and short players and masked them out of the data frame. And then we merged these with the salaries. So we saw that the median short player salary, so players that are shorter than 50th percentile of the NBA, on median are paid 9.641% more than taller players, their median salary, who are taller than 50% in the NBA. This further supports that teams are paying these smaller players more as there's more competition and they provide more value to the court. We wanted to see how much each positional and usage group impacts each game, meaning these high impact front court players, high impact back court, low impact front court, and low impact back court players. We wanted to see their statistical contributions on average to each game. So here we can see that the high impact backcourt players lead in 2 of the statistical categories, which our visualization is also going to support. But to get to this insight, we were able to mask all of the high impact and front court games played from the NBA stats clean data file, and compute all of these aggregates for each category and put them into a final data frame, which was returned down here. 2, we were able to make a bar chart with 4 of these bars for each category to fit into each statistical category contribution. And this supports our insight right here. We can see that these are all charted with the respective colors and categories. And this supports our insight in that the high impact backcourt actually leads in a lot of categories and is therefore more financially valuable to each NBA team, which we've seen through the previous data analysis. But we see that low impact front court players actually perform pretty well compared to low impact backcourt players. So that is something for NBA teams to look out for on the dispensability of big men in the NBA. How NBA teams are spending their money on their player minutes. So we mapped the five smallest amount of minutes on average in the NBA with the five biggest, and you can see some stark salary contrasts, and that these are dozens of times higher than the players with the smallest minutes in the NBA. Further, our visualization is going to support a trend with greater minutes and greater salary. However, even with the smallest minutes in the NBA, the smallest minutes are still getting paid north of $1.5 million. So not a bad gig for 3 minutes a game. Supports this last insight, as we can see that the average minutes are charted on the X with salary, and this should be in tens of millions on the Y. And we can see that there's a big middle of the pack range from 5 to 25 minutes, but after 25 minutes, teams really financially contribute a lot more to that salary, and they expect those players to play more minutes. So you can see that 25 plus minutes is really a team's big investment range for an NBA player. The greatest challenge. So we used a lot of powerful modules. The pandas data frame was the big one that we used to go through thousands of rows in data, and we used masking to get rid of data and also add new columns to this data. Our biggest challenge was definitely the rate refresh requirement. I was working on that for a while, but eventually I figured out that I could just shut the program down by using the time.sleep method, and then request after that sleep method is done, after the 1 second delay or whatever it was. And then what we learned from this project is we need a standardized data collection to advance the next generation of computer scientists. We had a lot of trouble getting even this type of data, and it needed to be cleaned a lot, and there were a lot of missing entries and wrong numbers and long numbers that were not easy to understand. And I think if there were some laws or regulations around standardizing data collection with these different companies, then we might be able to have a better generation of data analysts and continue in this world of big data that we are. Thank you for this class, and thank you for watching this presentation.